Okay, so we want to look at some applications here in construction of our trig. You guys with me? Okay, so here we go. We did these with our systems of equations at the beginning of this semester. What I want to look at now, let's say that this here is a 16 and 12 slope, and this here is a 412 slope, and this is a 40-foot span. I want to locate the position of that peak. So I want to find X here. How would I do it? Thanks, sir. Well, first thing I'm going to do is I'm going to find these angles. How would I find this angle here? Well, that is referred to as a heel angle. This part of the truss is what's called the heel. So that's the heel angle. It's the angle the truss forms at the heel. The heel angle is found off of the slope. That 412 slope can be thought of as a triangle that looks like that. So this angle right here is the same as that heel angle. That angle there involves the opposite and the adjacent side. What trig function is that? You had it. Tangent, right? So tangent of that angle equals 4/12. So to find the angle, it's the inverse tangent of 4/12, which is what, 18.43? 1843, yes. That's 18.43 degrees. Over here, that heel angle is going to be the inverse tangent of 16/12. Yes, 53.13. Perfect. This angle up here at the peak, the whole peak, not just on one side of it, is going to be found by adding those angles together. So 18.43, 53.13 is 71.56. Subtracting that from 180, this is 108.44 degrees, correct? So what does that allow us to do? It allows us to find the lengths of our slopes. How? You got it. 40 over the sine of 108.44 degrees equals, let's call this one over here, we'll call that slope A, slope B. So it's going to equal A over the sine of 18.43. Now I chose the smaller one again, but we didn't really have to because this angle is already obtuse. So we know we're not going to have a second obtuse angle. 40 times the sine, 18.43, divided by the sine, 108.44. I get 13.33 feet for A. Now, technically, I could find X right now. I don't need to find B, but I'm going to find B just because having that roof slope is going to be information you would need for doing estimates and stuff like that anyway. So 40 over the sine of 108.44 degrees equals B over the sine of 53.13. Now we know this is going to be between 13 and 40, right? Has to be that angle's in between. So we are going to cross multiply. Oops, wrong way. Cross multiply this direction and divide. 40 times the sine, 53.13. What'd you get? Okay, that sounds right. Yes, 33.73 is correct. Feet. So now then, we can look at finding x, which means we're going to be focusing in on this triangle right here. Looking at that triangle, that's a right angle. This is 13.33 feet, and this is 53.13 degrees. X is down here, which would be the adjacent leg. We have the adjacent leg in the hypotenuse, which makes cosine of 53.13 degrees equals x over 13.33. Since we are looking for a side, put it over 1, cross, multiply, and divide. Cosine 53.13 times 13.33 divided by 1 gives us x is 7.998. So in other words, that is 8.00 feet. X is 8 feet. So the peak is 8 feet from that end. What do you think? Good stuff? Yes, actually the slope ratios do work because we had no heel heights. We had 0 heel height on each end. If I throw in a heel height, that doesn't work anymore. Yeah. And I might throw in a heel height at some point. If this angle here is 30 degrees and this angle here is 120 degrees, this distance here is, oh, let's just make it 50 feet. How would you find that height? Well, what do we know from what we're given here? There is going to be another right triangle here, isn't there? Do I know any of the dimensions of that triangle? We know this is a 60 right here, don't we? That's 90, of course this is going to have to be 30. But we can't find the height. The angles only help if we have at least one of the sides, do we? We can find this side by doing what? Well, this is going to be 30 degrees, right? Adding up to, what's that? This is going to have to be 50. You are correct. So once you have, that's 50 feet, this over here has to be 43.3 feet. How did I get that? Well, let's say I use the 60. This would be the opposite. This is the hypotenuse. That's a sine. You cross multiply and divide. Sine of 60 is 0.866. So I'm going to have you guys try this in your notes. Let's say that there is 130 degrees. This here is 20 degrees, and this here is 80 feet. I want you to find that height. Okay, so for this one, guys, what'd you get for this angle right up here? 30 degrees. Okay, perfect. So this side here is going to be found 80 feet over the sine of 30 degrees equals, if I'm going to call this, we'll call it B here, equals B over the sine of 20 degrees. Do we know does it have to be bigger or smaller than 80? Smaller than 80 because that angle is smaller. So 80 times the sine of 20 divided by the sine of 30. 54.72 feet. So this is 54.72 feet. We know this angle here is how much? 50 degrees. So H, that's the right angle, H would be the opposite side. 54.72 is now the hypotenuse, which is a sine. Sine of 50 degrees equals H over 54.72 feet. Put that over 1, and we will cross multiply and divide. So sine of 50 times that 54.72 is 41.92. How many of you had 41.92 feet high? Okay. Well, let's look at something a little more complicated. Make Jasper happy here. So on this one, let's say that this is 40 feet and 40 feet. This angle here, let's make it 130 degrees. Back here, I'm going to call this one 60 feet and this one 80 feet. So this is basically like a house with an angled garage coming off of it. I want to find the area. Yes, sir. Yes. So these are right angles here and here and here and here. Now this is simpler because these spans here are both the same. It drastically simplifies this problem. We'll show you an example in a little bit where those spans are not the same. And we'll see how much fun we can have with that. So I'm going to call this here X and this Y. I want to find those lengths, X and Y, first. Or at least at some point I want to find those because I'm going to need them to find those areas. I'm going to cut this across here to make a rectangle. That's going to be a rectangle that's going to be 40 by Y. And I'm going to cut this across here to make a rectangle. That rectangle is going to be 40 by X. So all that's left for me to find is the area of this piece here. Well, since these spans are the same, of course, this is 40 feet and this is 40 feet, right? Since these spans are the same, if I draw this across here, it's going to cut this angle in half. These angles are each going to be 65 degrees, half of the 130. Well, from there, this is pretty simple. How do I find this length? This is 65 degrees. This is 40 feet. That's my right angle. If I want to find this length here, I'll call it A. That is the adjacent side, and the 40 is the opposite. It's going to be a tangent. Tangent of 65 degrees equals 40 over A, opposite over adjacent. So we cross multiply and divide. 1 times 40 is 40, divided by the tangent of 65. I get 18.65 feet. What's this dimension here going to be? Same, it's the same triangle, right? So that means X down here is 41.35 feet, and Y over here is 61.35 feet. Finding its area now is relatively simple. Piece 1 over here is 40 by 41.35. What's that give us? 1654. Piece 2 down here is 40 by 61.35, which is 2454. Very good. These two are identical. That's going to be 40 by 18.65, of course, divided by 2 because it's a triangle. times 2 because there's 2 of them. $746. Very good. We add those all up. $4,854 square feet. Does that look right? 4,854 square feet. Any questions? So again, we said that was a lot simpler because these two spans were the same. How does it become more difficult if they're not the same? It means, yes, those triangles here are not the same. Let's see how that works out. So let's say that this here is, let's go 120 degrees. Let's say this over here is 24 feet, and this over here is still 40. On the back of the house, let's go with this one being 40 feet again, and over here this is going to be 60 feet again. Now I drew this kind of poorly, but I am going to cut this across here to make a rectangle and this across here to make a rectangle. We know that this is going to be 24 by whatever. We're going to find these two distances eventually. This one's going to be 40 by whatever that distance is. So what we really want to focus on here is this shaped piece right here. We know this is 40 and this is 24. We know one other piece of information about, actually no, two. We know this angle up here is 120 degrees. It's still gonna be the same as this, right? We know this angle down here, 60 degrees. How did I get that? Well, this is 120, this is 90, this is 90. Those angles make a complete circle, so they add up to 360, don't they? I also know right angle there and there because I drew those in to be perpendicular. It's right angles. This is a lot like one of the problems on your homework. Yes, sir. What? Where? Ah, very good point. Let's change that. That 40 is probably a bad dimension. Let's make that 50. Good point. Well, you know what? No, no, I don't need to change that. I don't have to change that. It's 40 here, but it's not 40 here. Yeah, good point. I don't have to change that. We'll leave it as 40. Yeah, but it doesn't match up with that corner. This down here is shorter than 40. Because this here doesn't, the 40 goes out to here, not to where this hits. Does that make sense? Okay. So on this, I'm going to do this. If I cut it across here like this, there's absolutely no way to know what any of those angles are. So I can't cut it that way like we did before. I have to cut it this way. If I cut it this way, again, this looks just like one of the problems we had in our homework. How do I find that length? You're exactly right. Law of cosines. Right? How do we get that? What's that come out to be? $34.87 feet. Now that we have that, we can find these angles here, can't we? Let's find this one here. What's that? So we're going to have 30. Well, we actually want to find this one first, don't we? To make sure it's acute. Well, we know they're both acute because they have to be less than 90. But either way, we're going to do the 34.87 over sine of 60 equals 24 over the sine. I'm just going to put in theta to find that angle. So we're going to cross multiply. Sine of 60 times 24. Oops, get back there. Times 24 divided by 34.87. So that's the sine of the angle. We do the inverse sine. Get 36.59 degrees. 36.59 up here. That also, by the way, gives us an angle over here of 53.41 degrees. I'm going to write that outside. Yeah. So we can see it. This angle over here then is pretty obviously 83.41 degrees because those three have to add up to 180. This angle here then is going to be 6.59. So rather tiny little angle there. So now in this triangle, I really need to find this length and that length. So I am going to do 34.87 over the sine of 120 equals, I'll call this A over the sine of 6.59 degrees. 34.87 times sine of 6.59 divided by sine of 120. 4.62 feet. Yes, that's telling us then this dimension down here was 35.38. Next to find, we'll call this B over here. That would be the 34.87 over the sine of 120 equals B over the sine of 53.41 degrees. So we cross multiply and divide that one. 34.87 times sine 53.41 divided by the sine of 120. 32.33. Thank you. Feet. So now that means if that's 32.33, that means this dimension here is 27.67 feet. Now we can find our areas. This area right here, A is going to be what? 40 by 35.38. Does that give us? 1415.2 square feet. This one here, B, 24 by 27.67 is correct. $664.08 square feet. Now up here, I'm going to do this. This is going to be piece C right there. Piece C, we're going to have to use those trig formulas. So 4.62 times 32.33 times the sine of that angle between them is 120 degrees, divided by 2. 64 point, that doesn't seem right. I guess it is, yeah, 64.68 square feet. That's just a very slim little triangle there. And then this here, part D, is going to be 40 by 24. Times the sine of 60 divided by 2. Which is 415.69. What do we get when we add those all up? $2559.65 square feet. What do you guys think? Correct? It is a lot of work. They'll get worse before the semester's over. I got 4 more weeks. Draw this one out for us. So that's the gable end of a roof here. Go ahead. No clue. I'm probably just onto the hub. Okay, so let's say we've got this roof here. The span is 32 feet here. This span is, oh, let's call that 12 feet. This sticks out 16 feet. And our ridge up here, let's say the whole ridge is 48 feet. If I tell you that the slope on all pieces of this roof is 812, obviously it looks like it's a lot steeper than 812. But if I tell you all those slopes are 812, find the roof area. Well, I'm going to start right here. This is 32, but if I look at this piece, of course, is 16, right? How do I find that height? Eight over 12 equals 8 over 16, correct? So 8 times 16 divided by 12 should give us 12 feet. Oops, 10.67, sorry. That's 10.67 feet high. So then that allows us to find this length here by doing what? Pythagorean theorem, very good. The square root of 16 squared plus 10.67 squared. So second square root of that answer squared plus 16 squared. Okay, at 19.23 feet. Of course, that's the same over here, 19.23 feet, correct? So what I have, 19.23 times 48 times 2, because there's a slope here and over here. $1846.08 square feet. What that gives me is it gives me the roof area of both sides of the main roof. Now there's one issue that we're going to have to correct for. There's a piece here where that dormer cuts out of that main roof, isn't it? That area has to be subtracted. Then we have to add the area of the dormer itself. So let's look at this dormer and see what we can figure out. This is 12 feet across here, but if I cut it like this, just like I did over here, this is 6 feet. This height here, if I do 8 over 12 equals h over 6, I get 3 feet of height. Oops, not 3 feet, I get 4 feet of height. There, right? So then this slope length, the square root of 4 squared plus 6 squared, or 7.21 feet on both sides. But I don't know, I know this is 16 to here, but I don't know what this length is. I need to know that length of that ridge. If I'm looking at this from the end, it looks something like this. I know that back to here, straight up from here, that's 16 feet. I need to know this piece right here. So what I'm going to do is I'm going to draw in this triangle right here. That goes from where that ridge hits the slope straight down at a right angle. I know that the height of this here is the same as the height out here, 4 feet. If that's 4 feet, I can find this distance because this is an 8/12 slope. 8 over 12 equals a rise of 4 over whatever that dimension is there. I'm just going to call it x for now. That ends up being 6 feet. So that means this up here is 6 feet. Does that make sense? So that dormer area is a trapezoid. The trapezoid is, we have 22 for one base and 16 for the other. So that's 22 plus 16 over 2 times that slope of 7.21. Remember, for trapezoid, it's the average of the bases times the height. Now there's 2 of them, so that's going to be times 2 as well. Giving us 273.98. Square feet. Now we add that all up. We get 2120.06. But we still need to subtract out this triangle in here, right? Where the dormer covers up the slope of that main roof. But we now know what that triangle looks like. That triangle, of course, is just 12 feet wide down here. The height is the length of this slope here. Length of that slope is the square root of 4 squared plus 6 squared, right? 7.21 feet. So the triangle to subtract out has an area of 12 times 7.21 divided by 2. 43.6, I believe, or 26. $43.26 square feet. So we subtract that out. We get 2,076.8 square feet is the area of that roof. What do you guys think? Yeah, a lot easier than that floor area. Okay, well, we've got a worksheet for you guys to play with.